Hey, welcome. Hey, everyone. So, welcome to Containers from the Couch. If you're new to the show, this is where we talk all things containers. We talk all things AWS, as well as the open source community around containers, Kubernetes, all the good stuff that goes with it. So, generally, our shows are live, and usually we're live demoing some sort of feature or product or service. So today's going to be a little bit different. And what we're going to do today is this is a first show in a series that we're calling the Builders series. And if there's any other cool names you have, please feel free to tell me. I'm glad to replace the name. I'm never married to it. So the idea here, though, is we want to bring real customers, real users of our services, of containers, onto the show, and ultimately we just want to talk about what's going on. How are you using the services? What are you doing with them? To really, I can talk about it all day, but I really feel like when people who are actually doing it, day to day, when they talk about it, I think it's better for everyone all around. So with that said, I want to introduce Casey Lee. He's the CTO at Gaggle. And before I say anything else, Casey, why don't you just, introduce yourself, tell us a little bit about you, about the company, and all that good stuff.
Sure. Thanks, Adam. Thanks for having me on. I have the privilege of working at Gaggle. We are an ed tech company that we built software that school districts use to help protect their students while those students are using the Google and Microsoft accounts that they're issued through the school. We monitor the school issued accounts, looking for any signs of bullying, harassment, self-harm, even suicide. And we notify the school district, and they get the students the help they need. We protect close to 6 million students throughout the US, and we ingest a lot of content. I'm talking, I think last school year, it was over 6 billion files, 5 million emails we pull in, process, look for any concerning content, and then notify on. There's a series of automation, machine learning that's done against the content. And then the other part of our offering that we think makes us special is the human part. So we don't just let machines look for concerns with students. We then have humans reviewing it. And we reviewed over 40 million items that our machines found that could have been concerning. And that resulted in just over 20,000 what we call PSSs, possible student situation. It's our most serious type of incident. This is where the student is in imminent risk of any sort of harm. And then the real number is 1,400. Over 1,400 lives saved last school year. This is the most severe form of PSS. This is a student is making plans to take their life. We detect it, notify the school district, and they get the student the help they need and intercede before they can take their life. So that's what Gaggle does. We're keeping it safe using tech and using AWS to help make it happen.
Wow. I had no idea. That's amazing. As someone, as a parent of kids in school, that's amazing. And just to be there and to monitor for stuff like that. It's amazing how far we've come,
What's crazy is COVID. I mean, COVID had a huge impact on the mental health of kids. And we're seeing more than ever kids are in some bad spots, and it's cool to be a part of a company that has a mission of helping those kids. And COVID had significant impacts in mental health, but also in technical challenges. It totally transformed education. How old are your kids, Adam?
So we 11 and 8.
Okay, I've got a 14-year-old and a 16-year-old, and now they're back in school, but they've got a Chromebook in their backpack. Yeah. And they don't have notebooks and all that stuff. All their homework is all online now, all their assignments. So we saw a 400% increase in traffic. When all the kids went home and we were doing distance learning, the teachers had to come up with new ways and new tools of teaching. And so we saw this 400% increase in traffic. That traffic hasn't come back down. Kids are back in school, but the teacher's like, this is great. I love using these new tools to teach. So it's it's been a wild ride keeping up with the technology challenges of it.
Holy cow. Yeah. I mean, really the COVID, everyone being inside, everyone moving to relying on technology more and more. It's interesting to hear that 400% growth. So let's take that and let's talk about, a little bit about your architecture. So can you kind of walk us through, where are you running your applications? How are you running them in AWS?
Sure. So we still have some things not in AWS, but we have a lot of workloads running in AWS, and the stuff in AWS typically either falls in one of two categories, either running as ECS containers on EC2 instances, a little bit of Fargate, but a lot of ECS on EC2, and then a lot of our greenfield development is running in Lambda functions. That's what we will use for the compute. Do a lot with DynamoDB. The team's done a great job of architecting systems that are loosely coupled with things like SQS or Kinesis streams. But yeah, that's where we tend to spend the most of our time is ECS, Lambda, Dynamo, SQS.
That's fantastic. So you said, roughly how many like ECS tasks or services are you running day to day?
If I looked right now, it'd probably be over 2,000, but when you talk like back to school time, it's definitely north of 3,000 tasks are running at any one time. And these are mostly tasks that are in handling all that content. So we've got all of these documents coming in from Google and Microsoft. We've got to pull the content in, analyze it, scan it, and then if necessary, store it and notify the school district about the situation.
Fantastic. And then a great question came in. So, which, by the way, very common, what you said, that we see in environments is folks aren't just using one or the other, they're using a lot of everything, right? So but when we're choosing, between Lambda, Fargate, or, ECS on EC2, what's that decision-making process look like for y'all?
Well, I think it's an interesting question. So the other aspect to it is when the decision was made, right? So a lot of this work was started by the team 4 years ago. Fargate when did Fargate come out? 17, 18?
I want to say 18. I should know this.
Yeah. Sorry, I didn't mean to put you on the spot there, but it was definitely not at a spot where it made sense for us to be looking at. So EKS wasn't around at the time. Lambda was definitely there, but first of all, let's answer the question of containers versus Lambda. How about that? Versus functions. We had a long investment in Java. We have a lot of Java applications that were running on physical machines or virtual machines. Those migrate very nicely into containers. It's it's a good approach. It's a very solid approach to take the container and all the complexity that comes along. To take the application and all the complexity that comes along with it, containerize it, package it up, and run it up on ECS. So there's not a ton of friction in that type of replatforming. Moving to Lambda is a much bigger lift, especially when you're talking Java. You have these large heap size, large memory. You're talking large money, so it's not as good of a candidate when you're looking at taking an existing application and moving into. So Lambda, I guess our short answer is, for all of the new things we're developing, we start by looking at Lambda. Is this an appropriate workload to run in Lambda? If so, we build it there. If not, we run we continue to build with ECS.
Love that approach. And it's cool to hear you say that because, and by the way, it looks like 2017. I have 2019, 2017, but it looks like 2017. So you win, Casey.
All right.
That's a really good decision tree, I think, is, look at, are you replatforming? So are you just taking something that's running? You're not going to really do much modification. You want to move that into the cloud. I think containers make a lot of sense there. And oftentimes it may be tough to try to retrofit something in the Lambda, right? But whereas with Lambda, if you're going into this, it's a greenfield application, it's new, you can kind of develop in a more functional programming model, and you have control over a lot of these things. It's always good to look at Lambda first. I love that approach.
One of the guys I work with, Mike, is always talking about how what he loves about Lambda is it provides the perfect isolation for bad behaving transactions. So if we're pulling in content, you could have content that's extremely large that could have really poor, significant impacts on the performance of if it's like an application server and you got thread pools, you have one bad thread and you're taking down, you're affecting causing a lot of collateral damage to the other threads around you. Lambda is a great way to compartmentalize that and avoid impacting other transactions.
Yeah, absolutely. And I think, and there's many use cases. There's the length of time that your functions need to run, that your code needs to run, right? You have to kind of consider all the different limitations that go with it. But let's see. So there's a lot of stuff coming in here. So just see if there's any questions. Did you use Spring with Lambdas? So we're in the midst of making similar decisions ourselves. If not Spring, what did you use for injections?
Mostly Spring. There's a little bit of some of the teams explored Juice. I don't know why that didn't take off more. I don't know much about the reasoning there, but Spring is more or less our de facto a standard for ECS. There was, I wish I had more details on this. There was some challenges we ran into with using the out-of-the-box Spring SQS consumer. There's some framework that you can point in SQSQ, and it basically just pull messages and kick off transactions for you. And there was some really poor performance. I think it had to do with either a single threading of the pulling of messages or something to that effect. Watch out for that. Like if you're going to be using Spring and SQS, just read some of the issues in the GitHub repo. There was some conversation around that.
Excellent. And then, okay, so let's go to tell me a little bit about, I want to go back to the topic of, containers. So you're running your containers on ECS. How are you managing kind of the desired state of your infrastructure, of your container deployments? Where does that all live, and how do you work with that?
Yeah, that's gone through a lot of transition actually in the past couple of years. So maybe let me talk a little bit about how it was, and then how it is today. CDK is kind of the big conversation point in what it was and where it is. So previously, and not 100%, there's still some of this left, but previously it was all CloudFormation templates, either YAML or JSON, and they were stored in the Git repos, which was great. We were using Atlassian Bamboo to build the applications and then also manage the deployment of the CloudFormation stacks. So it was doing the job, but it did lend itself to a very single path for all teams to production, which presented a significant bottleneck. We're seeing lead times from when work started to when it was in production of close to 50 days. And we're seeing a deploy frequency across all the teams of about 4 deployments a week. And so the team was working really hard to go at the pace that we wanted to, but the tools that we had in place were not really lending themselves well to fast feedback, continuous delivery type stuff.
And quick question. So was that process also, like, was that a people thing, or was it really just more around the technologies and tooling?
So there was a people component to it. So the thing with the way we're using Bamboo is that it was it used Git flow type development, where we would have long-lived feature branches that would then result in long-lived release branches, because at the end of the day, there was really one non-production environment and one QA team. And so here's how it worked. And this is what we found. We found our number one problem was very long feedback loops for developers. So let's say you're on the team, Adam, and you're working on a ticket. You make some changes. Well, the first problem is you can't validate that change locally because you might be depending on some DynamoDB tables and SQS queues and maybe some other application. It's really hard to run all that. I know there's things like local stack that try to do a good job of it, but at the end of the day, you can't get real feedback. So what do? You create a branch, and then you move your ticket to the QA team, and you get in line. And when the QA team gets around to it, they go into Bamboo, and they deploy your branch, your build, onto the test environment, and then they test it, and then they send the ticket back to you and say your code sucks, you got to fix it. And so you can imagine that feedback loop was days just to get any feedback on a change that dev makes. That was our first real problem that we found.
Wow. So I mean that's so how did you solve that problem now? Because this is common that static environments for testing, relying on kind of you've made your changes, throw them over the wall, wait for results, wait days, which by the way, like I don't know about everybody else, but for me, like when I'm focused on something and I'm done with it, I want to have instant feedback so I can make the change. Having to come back to that work 4 days later, I've already forgotten about it and I'm on to something else, right? My brain is focused on a different problem. So
that's right.
It's hard to context switch back and forth. And I think that hurts developer productivity regardless. So
it makes that time even longer because then you got to figure out, what was I doing? I don't know. Yeah. Get back in it. So your question, how did we address it? The first thing we did is we said, how do we help the dev teams get faster feedback? The idea was if the devs are getting faster feedback, then we'll allow that code to get to production faster if that's where a lot of the pain was. So we invested in Control Tower and we gave every developer their own AWS account.
Nice.
I mean, I don't know. So curious what your thoughts are on that. There's more to the story, but just stop there. Have you seen that pattern? What do you think of that?
Absolutely. And I look, I'm all about empowering folks to give them the resources to do what they need. And I think we have to put guardrails in place, right? So I imagine there's billing alarms and checks and balances, and you're using Control Tower. You're doing it the right way. So you can have service control policies that control, like this developer can only work in this environment, can only use these services. Like you can control it. So with that said, I think this is a big deal. And this is what I see as a great end state for folks, is to be able to get those environments, build, test what you need in real time. I don't know if you've heard me talk about or seen me on Twitter talk about it, but moving the development, that testing cycle closer to the cloud, as close as you can be to real world testing, is going to give your developers the best results. So I love it. Sorry, I talked a lot because you asked me, but that's super cool. And I love hearing that, Casey. That's awesome.
So the first problem we had was developers are like, yay, I got my own account. How do I deploy my stuff to my account?
Yeah.
Right. Because the path to deployment before was Bamboo. And are we going to configure Bamboo with dozens and dozens of environments? And no, it didn't make sense. So that's where CDK comes in. We said, okay, let's make it so that devs can quickly deploy their applications from their own laptop. Right? I'm in my laptop. I don't want to commit code. I just want to push it up to my account and get fast feedback. So we went down the CDK path, and initially what we were doing was a lot of just wrapping those CloudFormation templates. There's a CDK construct called CFN include. So we were just CFN including a bunch of templates, and what that gave us was the ability to define, okay, here's the application with all the inputs, CDK deploy to any account, and you get your app. And so that got us real quick off the gate with CDK. It was pretty quick to be able to just wrap the existing apps. And then we would slowly start to replace those with native constructs. And then we'd see patterns and we'd create our own constructs and involved into its own. We use Python for CDK. It evolved into its own Python module with all of our core CDK constructs.
Okay. I'm sorry. I gotta stop you there because this is all really cool stuff I'm hearing. So first of all, this is a great migration story you're telling. And for folks that are maybe approaching this scenario in their own environments, this is a great way. If you want to go to CDK, but you have existing CloudFormation, this is how, if I'm understanding you correctly, Casey, you basically implemented the Strangler method where You just included all the previous CloudFormation template, slowly started to build CDK to replace those components. And then once that was, done, I'm sure then you went away with the CFN include and everything was CDK.
You got it. That's right. One sharp edge there. We had some SAM in our templates. SAM and CFN include, at least the time we were doing it, was not, those don't play well together. So if you got SAM in your templates right now, those need to be created as first-class constructs in the CDK apps.
Okay, that's good feedback there, because there was a question. SAM versus CDK, and this is an interesting question. We could probably derail this for an hour, the conversation. But I think SAM is very specific, right? Mm-hmm. SAM is Lambda only. It's very scoped to Lambda, but it's a very powerful, opinionated tool that can get you, to where you need to go. So I guess from your perspective, is that something y'all thought of?
There's a lot of things that SAM doesn't do for us. There's the Lambda versus ECS or other workloads, but at the end of the day, SAM is just CloudFormation. So you can put whatever you want in there. The thing that CDK gives us that was really valuable is those constructs. The fact that we could create those constructs that we needed. There's only so many ways to deploy an ECS service. We put them behind an ALB or we put them behind an SQS queue. And so we could take those, and rather than copying around, like physically passing around JSON files and, changing it just a little bit, now we can have a construct that has all the opinions how we want to see an SQS ECS service created in a construct. Someone just does a pip install with our modules, and they're off to the races.
And that's, especially for platform teams or even like smaller DevOps teams where you don't have the resources to sit and babysit everyone's environment, right? Mm-hmm. This is such an effective way to build a package and then just expose that package for your developers to basically, like you said, they pip install, npm install. They just add a couple, it's a construct, right? They create the object, they deploy it, but maybe they pass in 5 or 6 parameters, but all of your opinion and all of, your security, that's all baked into that construct that you're serving to the developers, right?
Yep. That's exactly right. The other thing that CDK was great for us was in some of those kind of cross-cutting concerns, permission boundaries or tag policies. You can put these hooks in. I forget what they're called in CDK. It's like anyways, you could say for any time somebody creates any IAM resource, a role, a user, group, automatically attach to it a permission boundary. And so we would give the devs access to create things like roles or so forth, but so long as they always had a permission boundary. And then this way, they don't need to remember in their CDK, they just have a one-liner that applies these tag policies or permission boundary policies. And then anything they do anywhere else or anything that an AWS construct or something creates gets all of the opinions that we have automatically applied.
That's super cool. So again, those controls are put in place all behind the scenes. And you mentioned the passing around JSON YAML. Like, it's just this hits me right in the heart, close to home, because I've lived the life and I've lived both sides, and I've seen what you've described and just the level of. So let's talk about that now. So you've made this move. Now developers are able to provision resources, test in real time, CDK deploy 8 million times a day if they want to. Actually, I'm not even sure if that's physically possible from a time perspective, but anyway, so what did that look like for them? I guess, can you talk about, do you have any figures or numbers you can share with productivity?
I do. I have one other thing that we had to solve first, though.
I'm jumping ahead.
We'll come back. The problem is now dependencies. So that's great. Now I can deploy my app, but my app depends on the other team's service, and their service might depend. So there's all these things. So just because I can deploy my app in my fresh new AWS account, how do I get all my dependencies? there's not a great story there for CDK. And so we ended up creating our own tool called CDKR because I don't know, I don't remember what the R stood for, maybe recursive, I don't know. But the idea is it's a real lightweight command line tool. And what it does is it allows you to define in YAML, because every good tool requires a YAML file. It allows you to define in YAML your dependencies. So my CDK app here in my repo depends on this other repo, and it's got the Git URL in the YAML file. That repo could have its own dependencies, which could have its own dependencies. Now I run CDKR, which is just basically a wraparound CDK, CDKR deploy, and then it first checks and deploys my dependencies. It does a Git clone behind the scenes, runs CDK on my dependencies, and resolves any dependencies it has. So I'm able to recursively CDK deploy my app and all my dependencies to my account. And so that was the kind of last little bit that we needed to let devs be able to deploy their app and all their dependencies in their own account.
That's really slick. And again, talking about everyone does things a little bit differently, and everyone has their own ways of operating. But I think we build off of general good practices, as all the things you're mentioning. So it's very interesting to hear that, because to get a real world test, you may want to test against service B, and generally in a microservice world, there's contracts, right? We expect you're going to have an SLA. We expect you'll version different endpoints and paths and so on. But again, to test in a real world, I want to test against a real world service, like as if this was production. So that's really cool. And is that tool, is that an internal tool?
That's an internal tool. We'd like to open source it. Just haven't gotten it extracted from where it is in the source code right now. So would love to open source that at some point soon, to be determined. Cool. So back to your question about results. So there's another number we metric, which is another metric that we measure called dev cycle time. So I was talking about lead time earlier. That was close to 50 days. Our dev cycle time is how many days a developer spends with the ticket, just the developer. And so that used to be around 29 days. And we brought that down to 3 days, because now a dev could deploy all their stuff to their local account and immediately within minutes instead of days get feedback. And we saw the throughput on how many tickets devs were completing went from about 3 per week up to 8 a week. So almost tripled our throughput and huge cut in cycle time.
Holy cow. That's impressive. And so when these developers when they're testing locally, I have a couple questions here. So I'll start with the first one though. So when they're testing locally, it's CDK deploys, right? It's just from my laptop, CDK deploy. At what point do my changes get into a pipeline? Are you still on Git flow?
Yep.
What's going on there?
Good question. So no, we're not using Git flow. We still use a feature branch, but we have goals around feature branch age. We like to keep those 48 hours or less. And so the feature branch goes through a pull request, and there's some automated tests that happen as a part of the CI build. But once that branch is merged to trunk, then we use AWS Code Pipeline to use code build to build the application and then deploy it through a series of 3 stages. We have an integration stage where we deploy it to an account that's not at the developer level, but at the team level, right? We used to have one shared account. Now there's one per team. And then once it passes the testing in that team account, it then goes to a shared staging account, shared across all the teams. All the teams have one pre-production account we call staging, deploys to that account, runs the tests against it, and then that approves and deploys to the production account. So it's really a 4-stage code pipeline: build, integration, deploy, staging, deploy, production, deploy.
Got it. And in that pipeline, do you have all automated testing? Do you have checkpoints where someone has to go in and click a button?
There are automated tests. I will not say that we've got complete automated tests. No pipelines go straight to production. We have manual gates before staging and before production. There are manual gates. Actually, I'm sorry, I'm saying that wrong. The manual gates are at the end of the stage. So we don't leave a stage until the manual gate is approved. So because you don't want new code coming into the stage while someone's doing manual testing. So we'll have a deployment step, an automated test, a deployment action, an automated test action, and then a manual gate action, all in each environmental stage.
Nice. Yeah, and look, we all dream of this world where we have every single test, we have 100% code coverage. It's amazing, but it takes time to get there, and it never happens overnight.
One of the other things we did there, Adam, was I talked early on about we had a shared QA team. We disbanded that team. We took the team and we moved all of the QA members into the individual product teams.
That's nice.
And that's also when we gave each team their own integration account. And by doing that, we said, look, we want you to be close to your product and know your product so that you can understand what type of automation needs to be built. And it's been great. We've invested in bringing in some new folks into all the teams, and the QA staff has done a great job of building automation and really improving the quality of the app through all those efforts.
That's amazing. And again, this is, we talk about technology, but this is the process layer that is equally as important. As you could use the coolest bleeding edge technologies, but if you don't have the processes to support a moving fast and taking advantage of and leveraging all those things that these technologies have, not much is going to change.
Yep.
So you moved to more of a trunk model, which is great. And that maybe we should talk a little bit about that for folks who are here that maybe don't, maybe don't really understand or are aware of the differences in the different type of deployment methods. So, I'm very much against long-lived feature branches, and there's a lot of pain. A lot of drift can occur when you have a feature branch. Then you want to merge that feature branch into trunk or to deploy it. There's so many different changes that can be different and so on. So talk to me a little bit about what that looked like for y'all.
Yep.
What ultimately made you decide to make that shift to go from long-lived feature branches to trunk-based?
Well, we knew it was the right thing to do. Okay. And Code Pipeline only lets you do it that way. You'll talk to people that are use Code Pipeline and like, why can't I get Code Pipeline to build for my feature branches? And it's because those strong opinions of trunk-based development live inside Code Pipeline. So we're kind of forced into that, which was a healthy thing for us. But there was a lot of learning that happened. So the first thing that happened is there was a feeling of, okay, well, hold on, we got to slow the pull request down, because a pull request merge results in something headed to production. And we had to get confident with going from, at the end of the day, we went from 4 deployments a week to about 6 a day currently. So the teams had to just get comfortable with that much stuff going on at once. And so there was a lot of gating and communication, out-of-band communication. Okay, hold on. Don't merge that PR yet, because we're letting this one go through. And we're not. One of the things the team did was they brought ideas of feature flags to the development. And we use Split.io for defining our feature flags. And each team is able to define those flags, and allowed us to separate deployments from releases. So we can deploy all the time and then either slowly roll out those changes or just give them to a subset of users and really reduce some of the risk with these changes. That allowed us to get more confident with letting stuff go out to production, even though, it gave us more confidence moving fast.
Yeah. And that's, this is all just like such good stuff, Casey. And feature flags, this is one of the biggest benefits of using feature flags and using some service to help manage those feature flags is you don't have to slow down. You can have that feature on in your lower environments, keep pushing. And when it's time to release that to production or even staging, right, you can canary it. You can use these features to slowly roll out that feature. And then if something doesn't go right, it's a flip. You flip that switch and it's not running.
Quick rollback. Yeah, that's right.
Yeah, so that's huge. So all of these things save time, and I love hearing these stories. So tell me now, but actually before we go on, there was a question around how do you set up your CI/CD with Lambda functions. So do you maybe want to talk about that? And maybe if you can talk about however deep you're willing to go, that makes sense. But how you build and deploy your containers, and then how you do that with Lambda, what's the difference?
Sure. So for the containers, so in all this, we have a separate AWS account, our toolchain account, which is where the pipelines are defined. The toolchain account is where the code build jobs run to build the application. And then if we're doing containers, we're building Docker images that we push to ECR. If we're doing Lambda, then we've got zip files that we're pushing to S3. We're not doing image-based Lambda functions. No reason why not. Just
okay, because there was a question about that. Are you using one versus the other?
Yeah, I don't have an opinion on that. I don't have experience with image-based Lambda functions. So the artifact, whether it's an image or a zip file, gets staged from the build stage of the pipeline. And then the toolchain account runs, the pipeline runs code build jobs in the toolchain account that runs CDK deploy. And CDK deployed makes it, there's some great constructs in place. I shouldn't say constructs. There's some great mechanisms in place with CDK to do cross-account deployments. So even though I'm running CDK in my toolchain account, I can target the other AWS accounts, the staging and the production accounts through IAM roles. And so CDK will assume that role in the other account and then do the deployment of the CloudFormation stack. So whether that's an ECS server, a new task definition and an update to an ECS service, we do that through CDK deploy. So CDK deploy will update the task definition, will pointing to the new image, and then update the service to point to the new task definition.
Nice. For
Lambda, pretty similar. CDK deploy, we're updating the Lambda function to point to the new S3 URL for the new version of the code.
So basically, you're leveraging these CDK constructs, which will do all of that for you, right? So you have your service definition in the CDK. Under the hood, CDK with CloudFormation is going to update your task definition to point to that new container image, handle the deploy based off of your deployment, configuration that you've set in your service. So pretty straightforward.
Pretty straightforward. That's it.
And I love the idea of a toolchain account, as you called it, like this kind of deployment type account where you don't have, first of all, no users are deploying CDK to production from their laptop, right? That's great. We don't want to do that. And we want to keep the hands out of the production account as much as we can. So, you have this centralized account that's in charge of these deployments. You're really isolating from a security perspective, who's making those deployments rather than what really, you're not worrying about who, because it's a machine doing it.
Right. And then we've got a great history of what was going on through CloudTrail. We know which deployments were made from the toolchain account. We can go back and confirm that all the right things were done.
That's super cool. So this is all really good stuff. I kind of want to switch a little bit. And if I missed anything, you've said so many great things. If I missed something, folks, please feel free to ask questions in chat. There's been a lot of great participation in chat, and Vlad is here in chat, and he just, Vlad has
a
wealth of information and opinion, and love hearing from Vlad. I think we're going to have to do a show with Vlad
on here
soon. So
cool.
So tell me about, let's kind of shift now to containers, and let's just talk about scaling. So I want to go back to the 400% increase. Can you maybe talk to me about, you recognize this. I have to imagine you didn't necessarily predict the 400% increase was going to happen. It just happened.
Right.
So how did you handle that? Is there auto scaling in your environment for the containers? Lambda obviously is a little different, right? You don't have to think about that. So can you talk a little bit about auto scaling your containers? How are you managing that? How are you doing that?
Yeah, sure. So for we've got two different kind of classes of containers: those that are scaling based on SQS queues, and those that are scaling based on more synchronous traffic behind ALBs. On the SQS side, we use step scaling. So we have scaling policies at the ECS level, and we do step scaling based on queue depth. So we say if the queue has X amount of items in it, then we'll just add Y new tasks to the service. And so we've got various steps that we will. What it allows us to do is all of a sudden, if we get a huge dump of traffic, we can very quickly scale up the number of tasks, not just linearly, but huge jumps when we see those big spikes in traffic. And this happens all the time. A principal sends an email to 40,000 students. All of a sudden, we got a bunch of content we got to get through, especially when they do that in the middle of the night. All of a sudden, we got a bunch of content we got to get through. And so this allows that scaling to happen pretty quickly. So that's at the ECS service level for SQS queues. But what's your thoughts on that for SQS and ECS?
Yeah, I mean, I think this is a common one. And there's multiple ways to scale. So you mentioned step scaling. So, step scaling versus target tracking auto scaling, two similar concepts, but they both scale your applications. The difference is target tracking really focuses on a target. I want to be at 100 or less messages in my queue. Scale as much as you can within the bounds that I've set to get there. So that's usually like an exponential type scaling event where it may start with 2, and then all of a sudden it's still we're not making any progress. So maybe it'll go to 100 tasks at that point, it'll jump. Whereas step scaling is very specific, that every, N amount of minutes, let's scale up N amount of tasks. Right. And so I don't think there's a right or wrong there. It just depends on the use case.
The problem I've found is that the places I've seen target tracking scaling work well is when you can identify a metric that is a per target metric. So we do target tracking for our ALBs because there's metrics like target response time per target or request per target. So if I've got 1,000 tasks, I need a number that is relative to the number of tasks running. And queue depth, if I've got 1,000 items and I've got 2 tasks, or 1,000 items and 1,000 tasks, that's not enough information. So if I could get a metric that was items in queue per task, then I could definitely do target tracking based on that, because I could say I want it to be 10. I want 10 items in queue per target, and then target tracking would work fine for me. But it doesn't exist, and we'd have to create our own custom metric that's doing that, and then you can pull it off.
And so the AWS Copilot CLI, they have a queue-based worker service, and they actually solve this exact problem.
Oh,
so rather than just focusing on queue depth, they do some math and build a custom metric to basically scale based on the amount of messages per task and what your threshold is there.
Yeah.
And I don't know for certain if we did this in the queue service in the CDK in our ECS patterns or in our ECS service extensions. I'll have to find out and get you an answer on that. But I believe we do. So,
okay, I'd love to hear more about that. That'd be cool. Yeah. So if
there was,
what I think I'm hearing you say is there's an opportunity, either it might already exist, or there's an opportunity for the CDK construct to manage that custom metric for you, and then you could use target tracking. That'd be cool.
Exactly, and then you can take advantage of target tracking and so on.
Because it's not very precise. We're making huge jumps based on spikes in traffic, so there's definitely a lot of waste in there for us.
Yeah, it makes sense. Okay, so very cool. So we have the auto scaling covered, and you're using CloudWatch, right? So it's all kind of native AWS services, CloudWatch with auto scaling, and that's all configured with the CDK there. Talk to me about cost optimization. So you use Lambda. Lambda is a great way to you pay for what you use. Even with Fargate, right? You scale in and out based on what you need. But you're using a lot of EC2 with your ECS environment. So tell me, what's that look like for y'all?
Yeah, that's a good question. So one of the things we do is we have shared clusters. So we will have ECS clusters that support many different services, maybe across different teams. So the challenge that presents is how do I know where to attribute the cost? What team do I attribute the cost for this cluster? The cluster has 2,000 tasks in it, and it's got 200 ECS container instances, EC2 instances in it. How do I know who to charge back for that? So we created a tool which we have open sourced called ECS Chargeback. You can find it on GitHub. And ECS Chargeback, the way it works is it starts with a Lambda function that grabs all the clusters in your account, grabs all the services in those clusters, and then for each service, it looks at the task definition and gets the CPU memory reservations. So it knows, okay, this service is asking for this much CPU and memory, okay? Then it hits CloudWatch metrics and says, what's the actual utilization for each of these services? So now I know reservation versus utilization across all my services. Okay.
Okay.
The next thing the Lambda function does is it hits the Cost Explorer API. It says, tell me my usage hours by EC2 container instance. So now I know, okay, we had this many usage hours. They're all mixed, right? Because they might be M4 large, M4 XLs. And then the last thing we have to do is hit the EC2. There's like a describe instance type API, which tells us this instance type has this many vCPUs in memory. And so that at the end of the day, what is all that math for? It tells us how much are we spending on average per vCPU and per gig of memory. How much are we spending? Because it's all spot, so it's, the numbers change. So now I know how much we're spending per CPU memory. I know how much we're reserving and how much we're using. Do some math and all of that, and then we're able to measure and monitor over time. We use Datadog for this type of over long term. We can measure cost per ECS service. Even in a shared cluster, I can tell you how much we're spending for each ECS service over time. And a more interesting number is we call it waste. How much waste is there per ECS service? And that's just the difference between the reservation and the utilization. If you reserve four vCPUs and you're only using one, then you get a bill for those 3 vCPUs that your service is using. And we present it as like a scoreboard. Like, think about the old school video games. We look at the order. The high score is the person that's wasting the most. And so we're able to look at which services could use some tuning, and we're able to visualize that in these shared clusters.
That's amazing. And Mace just shared this in the chat. So the link to this open source project, which there isn't a tool right now that solves this problem. So this is a really cool project, and I can't wait to get my hands on it and start testing it out, because this gives you that insight. And you mentioned something that is very common when operating EC2 as your compute in your with your orchestrator is unused resources, right? It's so common. I think the Datadog report every year, they talk about how much resource utilization, what's the average on virtual machines that are running in these clusters, and there's so much waste. There's 50% just being unused, yet there's a ton of instances in the cluster. So you're spending money that you don't need to be spending.
And no one does this on purpose. No one wants to waste, but we don't know. And so it's easier to hedge our bets and go bigger. Once you shine a light on it, then it's like, okay, we can fix this. I do have to give credit here. The idea for this tool was inspired by, there is a project called Kube Resource Report. It does the same kind of thing for Kubernetes pods. It tells you the difference between your reservation and utilization. A guy named Henning Jacobs created the tool. So got to give him a shout out, because that was really the inspiration. Said, how do we build this tool for ECS?
That's awesome. Okay, there was a couple questions. Before I go to them, you maybe high level. I'm going to ask the the elephant in the room here. I'm going to ask the question. You mentioned Kubernetes. So, so you're using ECS, using Lambda. I'm sure the conversation came up, or there was, consideration of Kubernetes. So why did you choose this, versus the other?
Well, at the time, EKS wasn't a thing, and running your own Kubernetes on AWS definitely took some lift. So ECS was the right choice at the time. Now it's a question of momentum. We have so much knowledge around ECS and how to run services really well at Gaggle. It doesn't make sense to pause and shift all that knowledge and get folks recentered on Kubernetes. Greenfield development, if we're doing something new from scratch, it would definitely be something that could be considered. But we have so much momentum, it doesn't make sense. I mean, just think about if you want to get a Kubernetes cluster going, what do you got to think about? You got to think about, you got to learn external DNS and cert manager, cluster autoscaler. You got to learn about ingress. You can have to learn about service meshes and Prometheus and Grafana and Jaeger. Like there's all these new tools that you got to learn. There's a certain amount of momentum that we have that would be very disruptive to pivot right now.
Yeah, and I think the other one that's big is just version upgrades, having to just be cognizant of the versioning of your cluster control plane and upgrading that. Granted, on the EKS side, I think we've done a fantastic job of making that really easy. It's just still something you have to be cognizant of, and that's one less thing for you all to have to think about. So let's see. Ganesh had a question here. I'm just going to pop it up. So we were talking about shared clusters earlier, and we only have a couple more minutes, so let's answer this, and we have to wrap. So what does security look like in your shared ECS clusters?
So we do make sure that we're aware of the type of data that's being processed in these. So we're not going to share something that has PII with services that don't need access to PII. So we do isolate based on data classification. But we also make sure that we use task level IAM roles rather than assuming anything at the EC2 level. So EC2 instances can't do anything other than run tasks. All the access level is really at the task level. So different tasks that need access to different Dynamo tables or SQS queues are isolated from each other.
And that's a great model. And that's the best practice model. And I'm not even I usually say good practice. That is the best practice model. Is you need to isolate per your container, right? So you have the ability to attach an IAM role to your tasks in ECS. And that's how you control the access, to AWS resources. So it's not, and it's good to hear you're not using EC2. We want to avoid using EC2, assuming that IAM role, limit the scope of what you need to access. So a nice little shout out here. Casey's the man.
Hey, Blake.
Let's see. Okay. Okay. Time flew here. Casey, I feel like you and I could have continued this conversation for hours. Like, it was so cool talking to you and just coming here and sharing this information with us. It's so awesome. So I really appreciate it. And just want to thank you for taking the time, because obviously everyone's busy. So it means a lot.
Yeah. Thanks for the opportunity, Adam. I do need to make sure it's totally clear though. Fantastic team at Gaggle that did all this work. Tamir, Jim, Keith, Jerry, Jeff, and all the dev managers, like these guys did all the heavy lifting here. I just get to share some of the results here. So doing cool stuff at Gaggle. And of course, we're always hiring.
Yeah, I was going to say, is there any link you want to share?
Gaggle.net, click on careers. We've got a lot of open positions. We always need folks that want to help build stuff. Awesome mission and cool group of folks to work with.
Awesome. All right. Well, thank you everybody for listening in. You can always reach out to us on Twitter. So, Casey has his Twitter handle there. I have mine here as well. Feel free to reach out, but thank you all again. This will be recorded, so you can go back to containersfromthecouch.com, find this, and you can watch through the whole session if you missed some of the earlier content. And other than that, just, hit that subscribe button, and we'll see you all soon. Thanks again, Casey.